So yes, now from my side, thank you to have you here, that you come, so many people. I didn't expect to talk in English, but hopefully I managed this today. Yeah, today's topic is RxAngular and a short comparison between the template syntax from RxAngular and the new Angular control flow syntax. But first, I would start talking about me. My name is rxIf. I'm 36 years old, married, one child, one dog. And I'm a front-end software developer about over 10 years. Yeah, I started with AngularJS at the very beginning, also in TypeScript at the very beginning. And yeah, saw many things and frameworks. And yeah, now dive into the agenda for today. Before we start, I would like to talk about the current native browser scheduling methods we have. After this, I show just shortly the Angular control flow syntax and what we can do about the rendering process there. And then we dive into the RxAngular. And after this, I show you a short example. And of course, the example code is also on GitHub. Yeah, then let's start. I guess, yeah, how does the browser can schedule our tasks? Tasks means async jobs or work we need to do asynchronously, or hard work that we want to schedule somehow, prioritize or do it later. Like, yeah, I just show the next line. Yeah, like listening to events, making network requests, and so on. These are asynchronous jobs, or we can even do heavy calculations in a separate tasks. And you may already know the event loop in your JavaScript in the browser. It's not really multi-threaded. Instead, it uses the event loop to queue tasks and then yeah, call each function from the call stack, and then it removes it, and then do the same again from the beginning. Yeah, that's it. And to add tasks and work to the queue, we have several methods. And also there's a difference between the task queue at the top and the microtask queue you see at the bottom. And I will also show the difference there, also with an example. Yeah, what do we have in the browser? You all know, I guess, set timeout and set interval. This is a callback to add a microtask to the macro task to the task queue, and its purpose is to, yeah, outsource, yeah, for example, heavy work to another, yeah, to a bit later, I would say. So when you use set timeout without any milliseconds value, then it's by default 0. So it will be the next macro task that is then triggered from the event loop. Furthermore, we have the request animation frame that stands between the micro and macro task queue. I will show this later in an example in the browser. And we have, maybe this is not so well known, we have this request idle callback. This can be used to schedule tasks that are not so important, so it's low priority. And it will be triggered when the browser is really idle, when it doesn't have anything to do. And you even get a parameter that says how much time the browser estimates to be there for your calculations, maybe. Additionally, there's a post message. This is actually event listening. So you can listen to the message event, and then you can post messages and data through the event listening system. And it's also used, for example, for web workers. And also, this is also a micro task. Yeah. And when you want to have micro task, you should use promises. For example, promise.resolve is a micro tasks. And the difference is that it's called far more earlier and before the rendering is done. And there's even a second method to queue a microtask. It's called queue microtask. And a new thing I didn't know before, but I guess RxAngular has it on its documentation page. It's scheduler post task. And here we have a native scheduling and prioritizing mechanism in the browser, but this is not so good supported in all. For example, Firefox doesn't support it, Chrome does in the current version. Yeah, and I show it in a few minutes. Here's just an overview. So we have first our synchronous calls, like I directly assign a value, use console log or so. And then we can use microtasks, for example, promises or queue microtasks. And then the rendering is done. So request animation frame will also call before the rendering. And then our macro tasks. So set interval, set timeout. Post task depend on what you define. For example, when you have, there are 3 options here, but I will show it. And then we have this request idle callback that is called at the end. And now I would switch to the browser. It's not working. Irgendwie ist das so schwer, ne? So, hopefully you can hear me. I have some code snippets here, and I will just run it in the browser for the sake of simplicity. It doesn't matter what I use. I just use a new page. Hopefully you can see it. And I do everything, I call here everything that I mentioned before. So first I just add the event listener for the message, post message thing I told you about. Then we have a synchronous call and everything has a number on it. So this is the order of the call. And then we can see how it's called in the queues. So yeah, we have request idle callback, set timeouts, queue, microtask, and so on. And you see everything is native. I don't have anything here. This is just the normal web browser console. And when I run it, you will definitely see the synchronous things. So these are called at the beginning, of course, because they are synchronous. It's just the console log and then the message. And after this, we have our queue microtasks as expected in the diagram. And the promise resolve is also then a microtask that is triggered afterwards. And then we get into the request animation frame. This is a special one between macro and microtasks. And then we start with the macrotask queue. And I even add some more nested calls for the queue. For example, first set timeout with a promise to see the difference between a promise and a set timeout. So the promise, the difference between macro and microtask, and when you call one another in the queues. So the macro, and when you call some microtask in the macro task queue, then it will get called first instead of when you first go into the microtask queue and then add a new macrotask queue. And as you can see, the request idle callback is called at the end, and this is also as expected. So the browser has nothing to do left. And I have another example with the scheduler. I will just reload here. And it's the same order, but I've pasted some scheduler post tasks here to see the difference. I've added the number .5, .6, .7, and .7 also always stands for the background priority, so you can say which priority your task should have. And you have these 3 options: user blocking, user visible, and the background. And then we can also see the difference. And as you can see, in the microtask queue, nothing changed. So this is the same output as before. But when we go bit further here, we have our 3 new post task calls that are called direct after the animation frame. And even the user visible was also triggered before the set timeout. So here you can more, have a better prioritization for your task you want to schedule. This is the native thing. So you can see when you switch the browser, it's not always the same order in different browsers. So this is hard to guess which order you may have. And that's where RxAngular maybe comes in and helps for this problem. Yeah. I would switch back to the presentation. So we saw everything of this. And now I would like to talk and continue with the Angular control flow. Angular by default provides us now with the if, for, switch, and so on. And it's a replacement for the structure directives, ngIf, and so on. And by default, or they don't have any scheduling mechanism under the hood. They use just a request animation frame. The source code is linked. And also you can find it in the RxAngular documentation. And the new thing is the defer block. The main purpose of this is to lazy load components, of course. So if you have a big component that's not so used so often, or not necessary at the very beginning of an application, you can lazy load components. But you can, or I wondered if we can use it for scheduling the render process in Angular natively with it, because it provides some special conditions like viewport and interactions. And I would recommend the official documentation for Angular. And just continue here. Can you see it? So we have this defer block, and I'm on the Angular dev guide for deferable views. Okay, I cannot remove the header. Beside the defer block that tells Angular to lazy load a component, we can have placeholders to say, okay, here's an element that is not really loaded. Maybe you can use a skeleton for the placeholder, for example, and then we will see this later in the sample code. You can prefetch your component and so on, and then the placeholder is replaced by the actual component when it's needed. Additionally, here's the code example. So we just use the add syntax with placeholder. You can even say it should be visible for a minimum of 500 milliseconds if you need this, so you don't have flickering also. This is the placeholder. I will show it later. Then we have the loading block, where you can say when the component is loading, you can show a different template. And also you have the option to add some conditions here, for example, a minimum, or after a few seconds, you want to show the loading, for example, an animated GIF. And we have also the error case when the module couldn't be loaded. And as I said, we have several different conditions that we can add to the defer block. There's on and when. On is for from Angular integrated conditions, and when we could use our own conditions by using or by providing a variable, a boolean that is then true, and then Angular knows it should load the component. We can even combine these conditions. Like here, we say on viewport means when the element or the component is in the visible area of the browser, or secondly, after 5 seconds. So when we combine several on conditions here, even or when conditions, it's always an or condition. So yeah, either of one should then be true. And yeah, as I said, the when condition could also be applied by using a variable. When it's a one-time operation, so when you have a variable that gets true and after a few seconds it's false again, it doesn't remove the component, of course. It will stay there. Yeah. And then we have this on condition idle. So you can say on idle. This is by default the default behavior. And it uses the request idle callback under the hood. So when rendering is done in Angular, when you have a full bunch of list items, for example, then afterward it will render your defer blocks. On viewport, I also already talked about. You can even provide another element. So when you want to have this defer block rendered when this element is in the viewport, this is also possible. And this works also for interaction. Interaction means a click or a key down event. Or yeah, you can say interaction on another element. So this is also working. And on hover is also working. And you can also provide another element for this. And then there's the last thing I didn't mention yet. On immediate means it will be loaded right ahead after rendering is done by Angular. Then there's no other condition, just loaded. And it's not in the idle callback. It's then directly after the rendering. So it could conflict with some other rendering process. Yeah, and that's it for the conditions. And you can tell Angular that it should prefetch the lazy loaded components. That makes sense. If it's a large component, then you can say prefetch on idle, or when a condition is true, and then it skips the loading template you can provide. So then you don't need this add loading anymore. Yo. And for testing, I would then continue later in the example code. Oops. So we have, oops, sorry. Yeah, so we can use the control flow syntax for simple lists like before with ngFor. It's no difference actually, but with the control flow syntax, you need to provide a tracking function. This was optional before. But it's now a simpler way to define the property you want to track. In this case, I want to use the ID of the item, and I can directly use the item here. This makes more sense and is easier to use. Yeah, and when I want to use defer, I can even use it in a for loop like I did here. And I can combine several on conditions and prefetch it. As I said, you can do whatever you want or need in that case. Yeah, and yeah, in that case, I use on viewport the unsorted list. So when the unsorted list is in the viewport, it will render all the items together, or when I hover the placeholder in this case, yeah. And it's prefetched. Yeah. That's it for the Angular control flow syntax. Now I will give you a short introduction to the RxAngular library. The RxAngular team also have its own state management. This is not the topic today, so I will just concentrate on the CDK and the template directives it provides. So you can easily install it by using RxAngular/template and CDK. The CDK provides the Rx strategy provider. So you can use the provider in your classes, in your services, in the components to schedule your working tasks. And the RxAngular template library contains all the directives and the push pipe you may need. What does it do? It enhances the rendering performance. So you can tell RxAngular how a component should render. So should it render immediately, or is it just the default behavior like like a list item, for example, can be just rendered normally. But for example, tooltip, when I hover an item, it should be rendered immediately. And this can be then specified by using these directives. Yeah, and before Angular 17, it was just a drop-in replacement. Now with the new control flow syntax, it doesn't work as a drop-in replacement because you have to rewrite your templates if you already use the control flow syntax. Yeah, but we did it in our project that we replaced all the ng structural directives. And now we are using the whole application RxAngular. And it improved our rendering process. So you don't have blocking rendering pages, for example. When you have a big page, even middle big applications, we have a site navigation on the left and right and main content. And when everything renders parallel, then you may get frame drops. And we solved this by using RxAngular. There are different strategies for Angular, for RxAngular. There is immediate user blocking, normal, low, and idle. And I will show you the difference in a few pages. First, how does it look like? For example, here's rxFor. It uses the same syntax like ngFor, so you can say let item of items. It also contains the track by function, but also here you have a simpler way to do this. You can provide a track by function if you want to reuse your existing code, but you can also say I use a string, and the string is then the property name of the item in that case. So it's the same as item.id. And additionally, you can provide a strategy. In that case, I provided normal, and all the others can be provided. And I'll show this to you later for testing. It makes sense to have this render callback, so you get notified when the rendering is done, because this changes in the testing. And there's also rxIf, of course. rxIf is not so, it's the same as ngIf. And there's also rxLet, where you can use or define, for example, view models. And it looks like the same like before when you have ngIf and the async pipe and your alias for the variable. But you have more control over the change detection, because you can also pass the strategy here, how this component or template should be rendered. And we have even context-rich state. So you know when the observable didn't emit anything, then you can use a suspense template. Or when the observable failed, so it throws an error, you can even use an error template. I will show this then in the example. And when you need to use the scheduling mechanism in your service or in a component, then you can inject the Rx strategy provider and then call the schedule method. And it's just an observable, so you can combine it, switch map it, merge map it, and so on. And here you also provide a strategy name. These are all that are possible. And the next screen shows the difference between them. When you think in a browser, we need to do our work in tasks. So we have 60 frames per second. And so one frame has around about 16 milliseconds to finish. And if it takes longer, then we see frame drops. And frame drops is here marked as the red line at the end, long task overtime. And this is something we try to avoid with RxAngular. And RxAngular split, for example, in an rxFor loop, splits up the rendering. So every item is rendered at a single time. And it doesn't get in this long task overtime step if you want to do this. And there's also the render deadline you see at the bottom. And what does it mean? When you have, for example, immediate, there's no render deadline. The render deadline is 0 milliseconds. So it's yeah, it should be rendered immediately. So this is a blocking strategy, but it's still yeah, scheduled and prioritized as you like it. User blocking has a render deadline of 250 milliseconds. So there's a time slot that you can, if it's then finished, then there's no blocking. But if it's not finished after these milliseconds, then the rest is exhausted. And the default strategy is normal. And here we have 5 seconds for the whole rendering. In the list, for example, we see it later, especially in Chrome. After 5 seconds, it will then render the rest of the list. Yeah, and but if it gets finished before that, then you just see how the list is built up. Yeah, and if you don't want to have any render deadline, you can even use idle. So it doesn't matter. But this is actually only for background task like backup things or sending logs to a backend or so. Beside these strategies are called concurrent strategies, so they are run in parallel. And there's also the non-concurrent strategies, native and local. And native is the same behavior as the async pipe does it. So it re-evaluates the whole component tree from the root when something changes. And the local uses detect changes instead, and this causes that only the component changes and its children will be updated. Yeah, as I said, testing can be hard with RxAngular, but I will show some workarounds, like using the primary rendering strategy or overriding it by using the render strategy config token. Or you provide an input for the strategy you want to change. And the third thing is, as I mentioned, using the render callback. So you get informed or notified about the rendering by RxAngular. Yeah. Now we dive into the code. I've created an application with Angular 17. It's nothing special. I start at the app component. Oh, sorry. Don't see anything. So I just, maybe I show it in the browser. So it's just a header, navigation, and we have a list here. We have some image rendered here, and you see some tiles. I can scroll it. It's 100 tiles. It's just an ngFor loop in that case. And the TTR means time to render. So there's a small component that measures the time to render. And inside of this component, I have a my slow function call. So this is causing the component for taking so long for the rendering. Yeah, and then I used the same list, the same template for all the ways we can use for all the implementations we have. So I've compared ngFor with adfor and adfor and defer, like I mentioned in the presentation. And then we come to rxFor. How does it change then? So there's just a router outlet here, and the big image at the bottom is this, just from Unsplash, some background image. And it contains also the priority. This means that this is visible at over the fold. So it should be rendered immediately. And furthermore, I have used the strategy provider here. We can see it in a few seconds in the browser console. I've used all the different, the native things, but also the post tasks and the strategy provider mechanism. So we see the order then. So we called idle first, and then low, and then normal, and so on. Sorry. But I will show it just to you here. will open my console. I will just reload. So you see the app component. Yeah, as before in the small example, it immediately triggers the native things like promise and queue microtasks. And then we have our RxAngular scheduled job that is with the strategy immediate, called directly afterwards. And at the very end, we have this request idle callback triggered here. And we have also the RxAngular idle callback called before the native idle callback. Yeah, so this is how it is different from the native things. So for example, you cannot say that you want to add a microtask in RxAngular, but you can prioritize at least this macrotask list. Hopefully I'm not too fast. And yeah, as I said, the scheduler is not available in Firefox. So we can even test this in Firefox. Here we have the same output, the microtasks. Then here we have our post task user blocking. So this is the highest priority. And then some timeout, so some other microtask is done. And then we have the user visible priority from post task. And at the end, but before the idle native thing, we have the background strategy from the scheduler. And the rest is the same. And now I would like to show you the ngFor implementation. So we have this strange component, it's print time diff. This is the component that shows the rendering time for itself. So when I reload the page here, maybe I do this in Firefox. Firefox is a bit faster. I'm on ngFor, so you don't see anything. There's even the image with priority is not rendered because my components inside of it taking too much computations. And I can even retry this again. And the time diff component renders the time. So it's a rough 5 seconds that is, yeah, we can go into it. In the constructor, I call it a slow function. It's just a calculation for some mathematical things. And ng after viewing it sets the second time. So I remember first time performance now at the constructor here. And then I use the second time and yeah, just use a computed signal here. And we have a list of 100 items. We have a track by function, like you know it. And then we just yeah, have the image. This is just a placeholder. And then also, again, the component that shows the time to render. And for the add syntax, for the control flow by Angular, it's looking actually the same. The template here is the same. We have the add for with our items and then the track function again. And when we try this in the browser, we can see it's actually also taking a bit of time. It looks faster. I don't know why. Before it were actually the same numbers here, like ngFor. When I reload it, I also see that everything is blocked until the rendering is done in the middle. And yeah, we can see the first element took about 2 seconds to render, and the last just some milliseconds, because then we have time when only a single item or component is rendered here, then it just needs 30 milliseconds. And then I tried to use the defer block to change the rendering a bit. And I can show the template to you. Here, it's the same list again. It's also the same template in the defer block, but I added some placeholder and a loading indicator, of course. And the error case is never catched somewhere because I don't throw any error. yeah, and at the beginning, I just used the viewport. When the UL element is in the viewport, it is all the time because it's above the fold, then it will be rendered. And this is causing this behavior. So we see immediately our placeholders. This is no complex logic. So this is then rendered. But again, it takes some time and it's blocking. Oh, this was fast, actually. Yeah, but it's more responsive, I would say. So when I reload it, you can see it here. The numbers for the single component are very low. When I move back to rxFor, even this number was very high, although it's above the ngFor loop, or yeah, for loop. So this can improve the performance already. And with the defer block, you can even do more optimizations. If this doesn't make sense because the UL element is above the fold. So we can try to use, for example, hover, and hover should be fine. We can, prefetch on idle maybe, then we don't see any loading. And when I now, you see now always the placeholder is visible, but when I go with my mouse over the placeholder, it replaces it. And you can see the time to render for a single component is very, very low, and I can then hover over everything. And this is also possible for interaction. So now I hover over it, but nothing is happening. I have to click it, and then you saw the loading indicator because I removed the prefetching. It's for a minimum because it's so fast. It's not really loading anything. So you can say I want it to be visible at least 300 milliseconds, and when I now click it, you see the loading part of the template. And is there anything else? No. Then, so we saw ngFor and rxFor doesn't make any so big difference, but using defer can improve the performance of the rendering if you have such complex logic in the components. And now we see the rxFor behavior. I will just show it here. You see it's immediately there. So there's you see also that the time to render for the single component, because it was rendered in a single thread, it doesn't need much time to render. And I have an overall time for rendering by using the render callback from rxFor. And it is around the same time. So the whole list needs about the same time like before with ngFor, but it's more responsive. When I reload it, you will see, I see immediately the loading progress. I can interact with every element, and I see the image to be loaded here at the bottom. This was not the case with rxFor or with defer. And what did I do? We see it here in the code, rxFor. I just used, instead of ngFor, just use rxFor, let item of items, my track by function I mentioned, and then we can provide a strategy. I can do it as a string, for example, normal, idle, or anything else. I used a variable for this. You can even change this on the fly when you need to, for example, on hover, you want to change the strategy to immediate, but for any other case, you want it to be normal or idle, then you can pass a subject to it and then just exchange the strategy name. And then at the end, we have the render callback, also a keyword from rxFor. And we pass also a subject here that is then emitting when the rendering is done. This can be useful later. So the template is the same. And additionally, I use an rxLet here. So I have a variable, another subject that calculates the rendering time. And here we also see the suspense logic, how it can look like. I just pass a template name here, And then I can say, okay, time for rendering is in progress. And here I use the immediate strategy, for example. And when this subject emits, it uses reduce to calculate the milliseconds. Then we see the template at the end here. And this is, this one. And when I reload again, you see the in progress, so the suspense template, and it's replaced then with the actual template. Okay. So this was the front-end part. Now you may want to test this. Hopefully you want to test this. And I will compare these. In ngFor, it's very simple. I can just use the debug element and query all the elements by using a CSS selector, uLLi. And in that case, I just expected to have the length I defined. So it should be 100 items. And then this should be true. I already run it. So currently everything is passing. And the same is working for rxFor, of course, because there's no deferring, no asynchronous loading. So I can use actually the same test here. And we have a difference in the defer components because here I have the same test added. And I was happy, it's still working. I just select the uLLi elements, but then I found out, or I remembered, okay, this could be the placeholder. Is it the placeholder? Because our placeholder doesn't have any image in it. It's just an animated diff here. I could try to select the image instead. And when I do this, then I've found out that, my test is actually not working as it should be because it's not finding any image in the LE elements. Here, so there's nothing found. And we can solve this by using a new function in the fixtures block, in the fixtures object. It's called getDeferBlocks. So you get all the defer blocks in your template, and then you can do something with it. And I will fix my test. Before we can do this, so before we can query all the items we want or we need, I get all the defer blocks, and I have to tell Angular that it should render to a specified type or state. We don't want to have the placeholder. This is the current one, I guess. We have these options. We can render the loading template, the error template, or the complete template. And we want to have the complete template, of course. And when I do this, I can use this query, and then the test should be green again. Yep, as you can see. And of course, you can test the placeholder things. You just need to render all the placeholder blocks for every defer. I don't know if there's any way to get the defer block by name or so. For now, it's working for me because everything is deferred the same way, and it's always the same defer block. But if you have several different defer blocks in your component, then you may use a different approach. And here I just use text content match to see if it's the placeholder content, and at the end I use the loading content, and then it should have these matches. So this is how you can solve this testing with Angular defer blocks. When you have rxFor, there's nothing like get defer blocks also or anything like that. You have to do it on your own. As I said, we have in the component, we have the subject items rendered, and it's public. And this tells us when the rxFor list is rendered. It emits, then it's a value. And now I'll show the test to you. So here we have the same test again. It's using query all again, but I have to wait for the items rendered. And when I don't do this, of course, it's not working anymore. No. So one test is failing because it got 0 elements, although it expected 100. Yeah, this is one solution you could use. I also tried to use, this is the same approach actually, to use the testing library. So you could think of that find all by role. It returns a promise, so maybe it gets all of it, but you will see it does get more, but not all, because it doesn't know when it's finished. So we see it here, it gets around 24 instead of 100. What you could also do here is when you want to use query all by row or so, then you could use wait_for. It's also a function from testing library. I remove this one. So I go into this wait_for, provide a callback, and when my query here doesn't have the same length I expect, then it just throws an error, and wait_for triggers itself as long as we have an error. And we can see it here. This should work. And after this, when I've waited this wait_for, I can use query or get instead of find, because I know these elements are already rendered. Yeah, this is passing. So this is another approach. When I don't want to use either one of it, then you could also use, I can try this, to provide the strategy by using an input. That's why I have this public input here. So you can change it from normal to native. Native means it's similar to the Angular way. And we can see if it's working. And it's still green. And I removed the items rendered awaiting. If you use always the default strategy in RxAngular, you could even unset it here. So it's just not provided, or yeah, maybe I go into it. So if I don't provide any strategy here, by default normal is used, or not by default, but what is provided here with this token. So you can override the default primary strategy by using this token, and you can do this in your test, of course, and then you don't need to add an input or the items rendered subject. You can just use this provider and say, okay, for this test, it's just native, and then your test will pass. Yeah. And that's it for now, I guess. Yeah.